Good morning, everyone. First of all, I want to thank the organizers for inviting me, for having me here in this wonderful, wonderful church. And, well, I will try to be brief and very focused, not in the technique itself, about just building this definition of cities, but rather on focusing on what can we learn on the use of new data, big data, let's say. My talk will be how to use information technology like Google Maps, OpenStreetMaps, etc. in a smart way for a particular purpose. What we will learn in the end is that we need real data in any case just to accommodate this new information to what we try to achieve. Let's start with a key phrase. Using the right definition of an economic phenomenon is the best way to analyze problems and find solutions from a policy perspective. We have learned, for instance, Andres and some others were talking about cities, but what is a city? A city is, this morning, when I was wearing my running shoes and I just went for a run just to visit the city, I saw that it's surrounded by a channel, okay, some water, and it's perfectly bounded. This is Hertogenbosch. Okay, that's great. But what is a city? Where a city ends? Not all cities are surrounded by a lake or just they are islands. So how do we define a city? Well, in general, first of all, of course, we have a clear idea that it is defined in a specific area. In general, we will try to define a city just for specific purposes. It's very clear that any purpose of defining an environment like a city has to see with policy making. It implies that it has to be within an administrative definition, let's say a country, a region, a province. I know that there are some cities that maybe there are or some economic spaces that are at both sides of the frontier, but in practical terms, it's very complicated. So let's say we concentrate in a specific area. Next, we define a city in terms of density, you have to be dense enough, and population size, minimum size, 50,000. Well, why 50,000? In some African countries, when we look at the World Bank data set, we see that 10,000 inhabitants can be a city. And even in some countries, just 2,000. We can say that this is an urban area. Well, finally, when we try to go beyond this morphological definition of a city, we find a functional approach with this. We take the underground, we take our car or our bike, and we go from our place, which is out of the administrative definition, and we commute every day to work or to do shopping or just for taking our children to school. We observe commuting flows, which are fine just to define what is a real extension of a city. The OECD, together with the European Commission, have developed let's say, standardized method to define this, what we call functional urban areas. This is based in 3 steps. First, analyzing, dense spaces. Let's define it with green squares, which are, of course, within some administrative thresholds. Once we have defined these high-density spaces, using satellite data, we also define a second threshold, which is the minimum size. Then you say that, okay, this urban core, can be the seed for a city. The second step has to see with polycentricity. It can be the case that one city is close to another. And because they are so close, we can say that, well, they are in fact the same city because they are so much connected. So, well, we look at if there is an sufficient amount of commuting flows between these areas just to say that this is an integrated area. The third step has to see with the definition of the hinterland, the surrounding area, telling us that, well, the city is not just this dense space, but also something beyond. What we try to do is just to find this in spaces where the definition for, or the data we need for defining these commuting flows is not available. In many developing countries, there is no commuting data. Why? Well, basically because the census did not collect that. And in fact, in many other countries, developed countries, this is also taking place because many censuses are not just universe census anymore. They are very large samples, but they are not universal censuses. So we have to try to find new ways just to overcome these problems. Our proposal is to use, as it has been done in the past, using satellite data just to find this high density, and also a combination of Google and OpenStreetMaps just to find this. Our proposal is just finding high density grid cells with satellite data. Second, connecting non-contiguous urban cores and defining the hinterland in situations when we don't have commuting flows. What do we do then? We basically work with isochrones. The isochrones will be found by using these Open and Google Maps databases. What we try to do in any case is just to say, if you have a very small urban core, let's say 50,000, your hinterland will be small. On the contrary, if your urban core, is very large, your hinterland will be very large. What do? We just try to find out a relationship between the threshold of the hinterland, the size of the hinterland, in terms of the area of the urban core. Of course, these, just for defining just the polycentricity of the hinterland, okay, we need data to do this. Our example is Ecuador. Ecuador is just the perfect country in developing terms because just it's in the middle of the world, it's in the Ecuador. If you order all countries and you skip the largest and the smallest, it's just in the median. And just this very typical country in many characteristics. First, this is the country we defined these high density grid cells, and this is the largest city, which is here. This is Guayaquil. Quito, which is the capital, is around here. Okay, it is not the largest, it's the one in the coast. And these are the grid cells. Once we have defined this and we have combined with our administrative definitions of the municipalities, we find a total number of 34 urban cores. And we say, well, can we say that Guayaquil and this other small city, they are the same connected? Are they connected? What we try to do is just to check if they are close enough. How we do this? And this is the point. We need to check if this is close enough. In which terms? We need to look at something that happened somewhere else. The best proxy we can get is Colombia. In Colombia, we have commuting data. Colombia is very close to Ecuador. And we see that we have a list of cities with polycentricity. And we check the size of the urban core of the largest city and also the distance between these potential cities that can be connected. Using this data, we found this solution. We do the same for the hinterland, for Colombian data. And by doing this, we find another function. The point is that, okay, we can play around with different minimal thresholds, different definitions of the urban core, etc. And that the key issue is that what we defined for Ecuador is basically a picture that we built using data from other countries, from somewhere else. And this is all, as you can see. My main message is, okay, it's fine if we have data from satellites, if we have data from satellites, if you have data from, let's say, TripAdvisor, okay, if we have data from anywhere, how can we trust it? How can I trust the isochrones for Ecuador from Google Streep Maps or any other source? We need to say that this data is good enough just to accommodate to reality. And for this, we need real data. If we only have the tastes of people from TripAdvisor, this is a biased sample of the society. We need to check it out with some real data. In our example, what we did is just looking at the best chance we had is just using Colombian data with our Ecuadorian data and check if we can accommodate our exercise with some external information. Right now, for this particular example, what we are doing is just working with the OECD and looking at something like 1,200 cities all over the world, functional urban areas, and checking for this relationship between the size of the urban core, the size of the hinterland, etc. This is fine, but this is for developed countries, OECD. For developing countries, we would need further research because we will need to inspect what type of community data we have in countries where we don't have massive transportation systems, as in many cities in developing countries, and many other circumstances that will not take place in developed countries, okay? So my fundamental message here is that whatever we do with this new data we can find out, etc., we will need to check if this is close to reality. It's fine if we use data from TripAdvisor, but at some point we will need to do a proper test with a universal, I don't know if it's universal, but just a representative sample of the society, and check if this data coming from TomTom or coming from mobile phones is really a picture of what we find in reality. Thank you.
I think there's time for one quick question before we go to the next speaker.
Thank you very much for your presentation. It's interesting because you make a first attempt to use some fine methods and different kinds of data. Of course, your approach is very much depending upon the thresholds you are using. This is very, very critical. You can find out possibly this is very much context dependent. Each country has a different threshold and so on. And then you call for testing for reality. And there I have major difficulties because I do not know what is reality. I believe my reality takes place in my brain and yours in your brain, so you might have difficulties to make appropriate tests.
Thank you, Manfred. Well, as for thresholds, well, let me tell you that the OECD is working with, for instance, a threshold of density of 1,500 inhabitants per square kilometer, just to be high density. But in other countries, this is lower to 1,000. And for China, they used 500. Okay? So in any academic work, what you have to show is just sensitivity analysis. How sensitive are your results to different thresholds? We did that. We also played around with generated commuting data using gravity model, commuting data generated from radial model, coming from physics, using also migration data from the census, which is flow data, but different perspective. So we were very careful with all these steps, but I fully agree that the definition will depend on different areas. What is good? The good point is that, well, we need an international standardized definition, and this is what the OECD and the European Commission and other governmental bodies, international governmental bodies, are trying to design. just this combined and, let's say, standardized definition. Okay? So this is what I can say.
Thank you very much.
Thank you.